Hi everyone, welcome back to Java 1 for All. In this video we are going to start one of the most advanced topics in Java, that is threads. Let's create a new package, f threads.test. Then just create a new class, threads test01. Okay, so we already saw a little bit about threads when we were talking about parallel strings. So what is a thread? Basically, it can be two things in Java: a line of execution or a object, because we have something called thread. So this is a class, and this class will give birth to objects that is a thread. Now, when we talk about threads in Java, it can be either object or a line of execution. And when we talk about line of execution, we are talking about the worker threads, the threads that are going to process something. So if you press on Windows Ctrl-Shift-ESC, you go to the task manager. You have here all the threads being used in the operating system. In this case, we have 217 processes and almost 3,000 threads handling these processes. And we have here the cores and logical processors, and basically the number of logical processors will, as far as I know, always be double of the number of the cores. So basically, the number of threads that we can use, like running parallel, that will actually run things in parallel, is 8. All the other threads is like you have different threads handling different processes, but it's not that they are always executing in parallel. So in the case of Java programming, the JVM is the one responsible for scheduling. So if you have like 5 threads, maybe all of them can run in parallel, but most of the time what's going to happen is that the JVM will decide, okay, thread 1, you are going to execute now, and then stop, and then thread 2. So this order is up to the JVM. It's almost impossible for you to decide which thread is going to execute what. So let's see how it works. In Java, basically, we have to care about 2 types of threads, daemon threads and user. What do you need to know about these ones? The Java program will be in execution, will be kept in execution until all the threads, the user threads, are terminated. So if you have one user thread running, the program will not finish. But you have daemon threads, even if they are running, if you just, for example, one of most famous daemon threads is the garbage collector. So if all your user threads are finished, even if you are running the garbage collector behind the scenes, the program will finish, because the order of importance for this one actually is way lower for based on the user thread. So how can we create threads? There are 2 ways. Well, there are more than 2 ways, but basically to get started, you can create here a class called thread example. And the first way is extending the class thread. This is a bad idea, because when we're talking about extending, usually we are changing the behavior. We are making a behavior more specialized. But in this way, we just want to make this class possible to be run by 2 different threads, or more, 2 or more different threads. And let's create here an attribute called character C. Final. Let's char. And let's create a constructor. I'm not sure why it's not finding a constructor, so let's do it manually. Okay, and then the code, the piece of code you want to execute in different threads, should go inside the run method. So we can press Ctrl O and override the run. Okay, now we just add whatever we want, and whatever we have here will be, or can be, executed in different threads. So first, let's say that I want the name of the thread that's going to execute this code. thread dot current thread get name. And now I will do a simple business logic for I. Let's say that I want I until 500. I want to print. I will remove the ln, the c, and I will just add some break lines here. Otherwise, we won't be able to see in the console. So I will want to break every time it reaches 100. Okay, so very simple program. And now we're going to see how we can work with this program. I think I may have. There you go. So let's create 4 objects. Thread example, T1, new thread example, and let's say this one is A. T1, T2, T3, T4. A, B, C, and D. Okay, so if we call the run like this, you will notice something interesting. The thread main is the one being called all the time. So we have main, and then we have A all the way to the end. So I believe we have 500 A's here, and then we have main, and then B, and then main again, C, and main D. Basically, when you call run like this, you are telling Java, okay, just use the thread main to execute the run from T1, and also execute the thread main to execute the run from T2. So we are executing one thread for the entire program. So it's the same thread that starts the program, it's the same thread that's coming here and executing everything. Now, what happens if we tell, hey, since you are a thread, just get started? We are going to talk about the state of the threads later, but right now we are going to tell, hey, when the main is the one responsible for executing this code, main is going to create all these objects, and then main is going to tell, hey, thread 1, the object T1, start a new thread. And then we will see this method being executed with different threads. Ctrl Shift F10. And the first thing you'll notice is that we don't have any order anymore. So we have T1, thread 1, then thread 3, and then we have DDDD, and then thread 2 and C. So the order, the time that each one of the threads are in execution is totally up to the JVM. You cannot control that. You can block the execution per each thread, but if you don't do anything, the JVM is the one deciding when each thread should execute. If you execute this again, you'll get a completely different result. As you can see, thread 1, 3, Ctrl Shift F10, thread 0, 2, 1. So you have no guarantees at all about how the code will be executed. Now, another thing is, this is one way of creating threads. The other way is implementing the interface runnable. So we can create here class thread example runnable. Implement runnable. So this is the best way, because interfaces were created exactly for this purpose. So telling that this class is a runnable, and we can copy this entire piece of code, and we remove the override here, and we rename the constructor. So how can we actually do this now? Let's comment this out. Let's first copy, hold the mouse wheel, and then Ctrl C. I think there was an option here where you could block yeah, I'm not sure. Block selection. It was somewhere. Column selection mode. Okay. Alt Shift Insert. So we press Alt Shift Insert. Then you can select the block. Okay. So now I'm going to comment this out, and I will come here, and then I will create. You can duplicate this. No, actually you cannot duplicate this. Let's do it manually. So we can create thread, and then we need to create the object here, thread. But this thread accepts a runnable. And guess who is runnable? This one. So we can come here and Ctrl D, Ctrl D, Ctrl D, T2, T3, T4, and then you can either pass the thread or you can copy here, right, runnable, 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 runnable. So Ctrl Shift F10, and you have exactly the same result. So basically, this is just an introduction to get started, but as you can see, we don't have much guarantees when we are talking about threads. It's mostly up to the JVM, but in the next videos we are going to see what we can do and learn about the states. So I hope you enjoyed. See you in the next video. Bye.